Hi there, I'm Monica Tu, and I just finished my PhD with Dr. Kevin Oxner in the Department of Psychology at Columbia University. In this video poster, I'll be showing you some of my recent work on how categorizing affect increases affective representational distance. Valence space varies continuously. We can experience valence anywhere from very negative to very positive to somewhere in between. But we also readily chop that space up when we categorize our affective experience using emotion words like distraught, worried, or serene. When we categorize our affective experience, could we actually be changing the underlying neural representation of continuous valence space? We investigated this by recruiting 25 young adults to report their affective response to a series of short videos during fMRI scanning. In the scanner, participants watched 7-second videos selected to elicit 4 different types of affect: neutral, positive, negative, and mixed, where they might plausibly experience a simultaneously positive and negative response. For each video, participants reported their affective response from positive to negative. Importantly, on one half of trials, participants had to make a categorical forced choice response and pick either positive or negative, while on the other half of trials, participants could choose anywhere along a continuous slider between positive and negative. We measured bold activity patterns in response to each affect category in parcels across the cortex. Then, within each parcel, we calculated the representational distance between spatial activity patterns for each pair of affect types: neutral and positive, negative and mixed, and so on for every possible pair. We then used pattern similarity analysis to measure how those pairwise distances between affect patterns varied as a function of whether participants had been reporting their affect categorically or continuously. We found that the average distance between categorical response bold patterns, that is, between any possible pair of affect patterns that were judged categorically, was greater than the average distance between continuous response bold patterns in the following regions: the left intraparietal sulcus, associated with representations of conceptual distance along a dimension, and bilateral medial prefrontal regions, associated with cognitive control and perhaps representation of affective category knowledge. When we look more specifically at differences in pattern distance between bold patterns specifically for positive and negative affect videos, we see that categorization again increases representational distance, this time in a broader set of regions, like, again, the left intraparietal sulcus and bilateral medial prefrontal cortex, as well as left ventrolateral prefrontal cortex, which has been associated with deploying cognitive control to select relevant information from long-term memory, the bilateral anterior insula, associated with primary affective processing and receiving interoceptive inputs from the body, and the bilateral lingual gyrus, associated with high-level visual processing, which here makes sense because participants were watching dynamic affective scenes unfolding. These results show that categorizing affect magnifies affective representational distance, especially between positive and negative affect representations, in regions associated with primary perceptual and affective processing, conceptual distance, cognitive control, and affective category knowledge. Activating category information and applying labels to our affective experience indeed appears to make representations of those experiences more neurally distinct. Future research can expand upon this work to investigate individual differences in how categorization might change affect representations, and how those differences might relate to individual differences in emotional health and well-being.